Hello, friends. Welcome to Enlightning. I'm here today with Ed Warnicke, and Ed's going to teach us about network service mesh. Welcome, Ed. Will you tell us about yourself, please?
Absolutely. So my name is Ed Warnicke. I'm a distinguished engineer at Cisco Systems, and I've been doing open source and particularly open source around networking for more than 2 decades now. So going way, way back in all kinds of areas.
This is
And so
exciting.
I'm here today to talk to you about network service mesh.
Heck yes. I'm so excited. We've been doing a series on service mesh. So we've covered like a general Kubernetes networking episode. We've done Istio, Kuma, Cilium. I'm missing one, Linkerd, and now this the cherry on top. So I'm very excited to hear from you, and especially hear from all your experience and getting from where we were before to now, whatever those things
Mhm.
are.
No,
Learning what those things are. Yeah.
that is a lot of excellent background actually for the discussion about network service mesh. Because it's a little bit different in its approach and what it's trying to provide for people than what you get from more application-oriented service meshes like Linkerd,
Mm.
Istio, Kuma, etc.
So it's less application focused. Okay, we're getting into the juicy bits too soon. We're supposed to keep this part light and fancy free. We're supposed to talk about like recipes and stuff. First, I want to say hello to everyone who's joined us in chat. We say hi and where you're from, please. And Thindle's here. Thindle's like, what? 2 Enlightnings in 1 week? You spoiled me. I'll tell you what I'm doing. I have another show called You Choose, and I'm covering. For KubeCon, Victor and I got a talk accepted where we're doing a choose your own adventure through the security landscape of the CNCF. So people, so I'm trying to learn like 20 security tools and like deeply
Only
enough to give
20?
a talk.
That's fewer than I expected.
Actually, I think it's 20 to 30. I haven't counted kind of on purpose because then I would just cry. No, it's going to be great. It's going to be awesome. But those of you who are watching, I would love if you drop your name in the chat, say where you're visiting from. I'm a solid Gen Xer, and I'm very impressed every single time I stream with how this is a global experience. Especially since Ed, you're with me in Austin, so we're not so global right here. We're just
It's a lot
across
more
town.
local.
Yeah, yeah. so, tell me something light and fancy free about yourself.
Ah, so I used to spend a lot of time and energy being an acrobatic bass, so I spent a lot of time tossing people around up
Whoa,
in the air.
that's
And in fact,
awesome.
that's actually how I met my wife. There's this lovely picture the first time we met where I'm standing there and she's standing in my hands and I'm holding her entirely above my head. Um, she usually comments that I was very supportive. Um,
Oh, that's the coolest. I just went to like an acrobat showcase last night. That was like at a bar. It was like they hung rings and like
oh, Lyra,
scarves and stuff
yes.
from the ceiling. Lear, yes.
Mhm.
And I also took a trapeze class on my 44th birthday last year. That was fun. So
Mhm.
I'm very impressed. Basically, I know enough to know how much I don't know in that area. So that's super cool. Thindle's introducing themselves. Thindle is Eric from the Frozen Wastes, and that's Scandinavia, but I forget what country you're in, Thindle. And then Thindle has an emote, so that is Zelda, Thindle's cat. Thindle's a regular viewer, and I'm glad Zelda's doing better now. That's awesome.
It's always a
Sweden,
good sign
thank
it's
you.
always a good sign when a community has its cats about. There's another open source community I participate in where during the sort of lull when everyone is forming up for the weekly meetings, cats
Mm-hmm.
and bunnies and other furry creatures make their appearances.
Oh, that's the best. Yeah. So I'm going to prep for this. I'm going to put network service mesh links in the chat, and I'm going to move behind the light board. But I do have cat decorations, and I have a cat. I have a lazy little lady on my bed right now. She's a sweetheart. But what the thing, so I have a new setup for those of you who watch regularly, and now I actually have a second computer over there, so I don't have to carry this one over to the corner like I used to. But the downside is, I don't know a way around. I have to disconnect my sound and then reconnect it over there. So now now I'm in a position where I'm asking my illustrious guest a question and then absolutely not at all listening to the answer. And then immediately muting. So, what would you like to talk about that I'll have to learn the answer to later by watching the recording? I,
That's a
uh,
good question.
you could, one thing that might be interesting, I just put this network service mesh community link in the chat.
Mhm.
Do you want to
Yes.
talk about that?
Oh, sure.
And
So,
that's okay. Bye.
see you. Um, no, the network service mesh community link that Whitney just dropped into the chat, that'll point you to the jumping off point for all things community related for network service mesh. So if after all of this you're inspired to get involved, that will show you where we hang out in Slack, how to get there. It will give you a good notion of how we talk to ourselves, where the community meetings are, where to find the meeting minutes from the community meetings. And there's also a lovely map there of the repo structure for network service mesh, because we tend to run a multi-repo setup, and so we have a lot of places where patches that come into some repo will, upon merging, cause PRs to be pushed downstream to update Go dependencies. And then CR jobs, CI jobs run on those, and if they pass, then those patches auto merge and so forth. And so it's a fun little map, because not only does it draw out and link you to all the repos, but if something goes wrong in the process of auto propagating changes, the links will turn red. You can follow those, they red and turn into links to the PR that failed. And so you can go see where you need to go make corrections or figure out what went wrong. And that's kind of, Findle made a comment, that site has a scary amount of tree node boxes. Yes, but it's SVG, so you're going to be okay, Findle. So, the tree node boxes do not bite.
So, how long has network service mesh been around?
So network service mesh, I believe, has been around since about 2000. I think we joined the CNCF in 2019 originally.
Okay.
The concept has been around since I think 2018 or so. It sort of
Okay.
started off as a, hey, wait, what if we kind of idea that caught fire, and so we wound up actually building the thing.
Nice. That's amazing. I like those ideas are exciting. It feels like there's electricity in the room when something like that happens.
It worked out rather well. It started off as I was scheduled to give a conference talk, and if you give too many conference talks, you wind up in this place where you write an abstract you could fill in anything into. And
A
I had
Mad
this
abstract.
basically, because you don't know what you're going to have finished by the time you get there. So you leave
Okay.
yourself space to do something amazing or to
Oh,
fall back on whatever it is you've managed to succeed in getting done. And that particular
smart.
talk had not gone well, in the sense that I found myself sitting there 3 hours before the talk going, okay, now what am I going to write on slides? And had this very weird idea that became network service mesh, and went and gave the talk on that. And I kind of got the clue that it might be a decent idea, because it started turning up at other people's talks the next day. So
Oh, wow.
that was a first hint that maybe there was something there.
That's exciting. But also surprising to me how many people are writing their talks at that last of a minute.
Oh, I used to classically do mine at 2 o'clock in the morning, day of.
Yeah.
So there we go. And now Whitney's back.
I was surprised. Oh, I gave like a day zero talk at KubeCon, and then someone asked me if they could take my illustrations that I made for that and put it in their presentation like the next day. And I was flattered, but
Fun.
also like, you don't have your slides figured out yet. Oh,
There's more of that going around than you realize, actually.
yeah, I'm
It's
learning.
it's
I like
always
it.
hysterical, because the Linux Foundation will send out emails exhorting you to attach your slides to your talk 2 weeks before the conference. And I'm sure there are fantastically organized humans who do that, and God bless them, but that's not me, and it's not many of the people I work with.
I think part of the reason I want to plan ahead, or have wanted to plan ahead more in the past, is because I'm learning. I'm not comfortable enough in my knowledge yet to just like talk, but now I'm getting there. I'm not where you are. I'm very far from that, but I am much more comfortable than I was, which I like. And and then Findle said they used AI to make slides, and like only two slides had words. I like when slides don't have words or have very few words. I think the words should come from the speaker.
Yeah, I tend to agree with you it's sort of this dichotomy that I've found over time working in different environments is that the best presentation slides are the worst slides for reading later. And so occasionally you find
Yeah,
yourself in circumstances where you're making a slide deck that you intend to present, and then people pass it around later and no one understands what's happening because they're not hearing the words over the top.
yeah, that's a good point. All right, here we are. This is the place that we were headed toward, and now we've
Mhm.
arrived. So let's talk about what the world was like, I guess, that KubeCon before network service mesh came to your mind. What problems were you seeing in the community that you were like, hey, we need something
Well,
here?
Kubernetes, in terms of networking, was having a massive crisis of success, right? So crises of
Okay.
success are characterized by you do something amazing and it ends up producing downstream problems of your amazingness. Um,
Uh-huh.
and so one of the things that Kubernetes had done absolutely brilliantly was rather than just photocopying the same old, you plug the Ethernet cable into the box and you treat it like an Ethernet cable going to a switch model of networking, which was
Mm-hmm.
getting very long in the tooth. Kubernetes in its networking model basically said, what is it we actually want from our network, right? What are we trying to
Uh-huh.
do? And the
Uh-huh.
result, and I know you've had an entire show on this talking about the basic Kubernetes networking model, is you got this very simple networking model that more or less says every pod can talk to every other pod at
Uh-huh.
layer 3. So when we talk about networking people like to talk about layers. And so they
Mm-hmm.
will talk about layer 2, which is just the link layer or Ethernet. And then layer 3 is the point at which you get IP addresses and you talk to people at that layer.
Okay.
And so,
Will you repeat layer 2 is what?
absolutely. So layer 2 is just hey, this is the layer at which we have Ethernet. Everything has a MAC address. You
Okay.
broadcast things. So it's the Ethernet layer, essentially.
Okay.
Um, there are, in principle, other kinds of layer 2s in the world, but we've been stamping them out for decades and we'll succeed one of these days. Um, and then layer 3 is where you get IP and IP addresses.
Okay.
And so you get the ability to, say, please go send this to whoever is at 1.1.1.1, or
Uh-huh.
whatever the IP address is. And
And
so, good.
so it used people were connecting at the Ethernet layer back in the day where you had to say your port number with your container to tell how to
No,
connect to it, and then
literally, you get entire things like OpenStack where their base layer they reasoned about was the layer 2 Ethernet.
uh-huh.
And in Kubernetes, that layer 2 isn't even a concept, right? You don't talk about it, you don't reason
Okay.
about it. Everything starts at
Uh-huh.
layer 3, which is the right way, right? So every
Uh-huh.
pod gets an IP address, and every pod gets to talk to every other pod using its IP address,
Uh-huh.
which is the very base level. And then
Uh-huh.
um, they layered on the ability to isolate pods
Uh-huh.
using network policies, which you probably
Yep.
talked about in your other podcast. But they did
Yeah.
it in a way that was very cool because they basically said, rather than enumerating for you the pods that we want isolated, we will give you a
Uh-huh.
selection criteria based on labels to
Uh-huh.
determine which pods are to be isolated. And then we will let you have another selection criteria to determine which pods are allowed to break through that isolation. So a very logical, application-oriented way of looking at it,
Mm-hmm.
right? So you had reachability at layer 3, you had selector-based isolation, and then the last piece was services, which basically said, and we'll let you logically specify a service that can then be connected to any selected set of pods that provide that service, right? So that was the last piece of classic Kubernetes networking. And this was a really great model for most purposes, and it did fantastic things. The one problem you had with it is that if you needed
Uh-huh.
something that wasn't this model, you were shit out
Uh-huh.
of luck.
Okay. Okay.
And there were a bunch of people who did have needs that didn't fit neatly into this model. And
Uh-huh.
they were trying to drag back in the whole let's start at the Ethernet level mindset, which struck me and a lot of other people as a terrible, terrible idea. Let's not retrograde. Let's not move in a retrograde fashion. And that was sort of the first problem that got the idea of network service mesh going, because at the same time that this was going on, you had the big bang from service meshes that were coming up. So Linkerd had been here for a little while. Istio was making a big splash. And the service meshes were thinking at a higher level. They were thinking up mostly at what is called layer 7, which you can sort of shorthand in your mind as HTTP. So
Uh-huh.
how do I discover where all the services that are talking HTTP are? And how do I route all of my HTTP messages to those services? That was sort of the
Mm-hmm.
remit of application service mesh. And it's a really cool set of ideas.
Mm-hmm.
And so the big idea for network service mesh was to say, okay, what if we rummage through the pockets of service mesh and steal the relevant ideas and figure out how they would project into lower level networking, like layer 3 networking.
Ah.
So one way of thinking about this is to say, in application service meshes, the payload that you're moving around is that layer 7 payload. It's an HTTP message. In
Uh-huh.
network service mesh, the payloads that we are moving around are layer 3 messages, like IP packets. And
Okay.
so basically that was the starting place. And so you say, okay, if you're talking about HTTP messages, the service they're receiving is an application service. I send you a GET to a URL. You send me back the response from that GET that I sent to the URL. When you're
Uh-huh.
talking about, you're providing a service at that layer 7. When you're talking about layer 3 payloads, I send you an IP packet. You do something with that IP packet. Maybe you route it to some destination. Maybe you change it in some way.
Mm-hmm.
Possibly you drop it because you're providing security. Maybe you take a note of it for observability. But you're
Mm-hmm.
fundamentally reasoning about that lower layer of
Mm-hmm.
things. And that was sort of the original impetus of the idea. And we were originally thinking about it in terms of how do you allow people to get different kinds of networking at those lower layers than you can get normally in Kubernetes.
Okay. I have questions. I want to
Absolutely.
acknowledge I want to acknowledge Thindle. Thindle was like, oh, we're talking about the 7 layers. We're talking the 7 open
So
system
the
interconnection
OSI layers
model.
and
Yeah.
I apologize, Thindle. I've been trying to describe them as we go because I know like not everyone is oh. So Thindle has this comment about the 8-layer model. Level 8 is the meatware layer. I always reasoned about layer 8 as being the executive management layer, but yes, it's the humans. It's the messiest layer.
Oh, by far. Egos. What's the model for navigating egos? Um, so I guess you're telling me the what, but you're not telling me the why. Like, why do people want to be able to move? Well, first of all, are they moving L7 stuff down to IP, or are they just moving whole different information?
Well,
That's question one.
think of the
Yeah.
L7 stuff as living on top of IP. So every time I
Okay.
send you
Yeah.
an HTTP message, that gets
Uh-huh.
broken down into a bunch of IP packets that get sent over
Okay.
the network.
Okay. Okay.
Now, but there are lots of things that live on top of IP that are not necessarily um, HTTP L7 kinds of messages that Service Mesh deals with well. Um,
Okay.
so the original reason that this had come up was you had a bunch of people who were telecommunication service providers, like your local phone
Uh-huh.
company, AT&T, Verizon, Deutsche Telekom, and they were trying to figure out how to deploy containers in Kubernetes that could process the network traffic that makes everything we know and love work.
Oh.
That was the
Okay.
original
So we're like,
impetus.
yeah, bringing it up here to process it just to put it back down here. And
Well,
then like why
but
do
they
that
shouldn't be
extra work?
looking at what's up here because that's not their
Uh-huh.
job. Right? And in
Uh-huh.
fact, most of what's up here is encrypted, so they can't even see it. So even if they wanted
Okay.
to help you up there, it just looks like noise to them, right? It's a bunch of random bits that have been encrypted.
Uh-huh.
But they do need to be able to look down here so they can route that traffic to where it needs to get going. They can do all the other things they do in terms of processing packets. And they wanted to deploy containers that would process those packets for them to
Uh-huh.
virtualize things that previously had been in hardware boxes. And that was sort of the original impetus. Now, as we went along, we discovered lots of other useful things you could do with the concept. So that ended up being relevant to what are sometimes called service providers, think people like your phone company who move a lot of traffic around.
Uh-huh.
But what we realized was that there's one other thing about Kubernetes networking that was a good choice design-wise that was made at the time, but is very limiting. And that is all those
Mm-hmm.
Kubernetes networking things that we talked about earlier, they're all what you might call intra-cluster networking. They're all about how
Okay.
traffic moves around inside a single Kubernetes cluster. And it turns out that it's really easy to stand up clusters. And so lots and lots of people will stand up a cluster, a bunch of clusters in GKE, a few clusters in AWS, some clusters in Azure, some clusters on-prem. And now they have the problem of how do you communicate between all of these clusters? And
Okay.
there are some things you can do at layer 7 with traditional service mesh, but not everything lives up there. So for example, when you're talking about databases, many databases have synchronization protocols that somewhat predate HTTP being as popular as it is now. So
Mm-hmm.
they've got these very funky, sometimes proprietary protocols that live on top of IP. And what we realized was that because the way network service mesh had been designed, the way it was designed, it was not welded to a single cluster. So your network
Uh-huh.
service didn't have to live in a single cluster. It could span any number of clusters, regions, or whatever. That it became
Uh-huh.
an ideal way for enterprise workloads to connect themselves to a common domain that let them have the connectivity, security, and observability they wanted for just those specific set of workloads that needed to communicate. So it's not plugging different clusters together. It's saying, I've got a workload over here and a workload over there and a workload over here. And those are actually databases
Ah.
that need to run database replication. So we'll plug them all into a database replication network service that just
Uh-huh.
is just the little space the databases use to talk to each other. And they just need basic IP connectivity.
Okay. So I'm trying to boil down everything you're saying into like a list of problems.
Yep. So
So I'm
hard to
trying
move
to
traffic between workloads in different clusters or different cloud providers.
okay. And then when you do you mean clusters in cloud providers, or are we talking also about like workloads running on VMs and other cloud providers? Are we at a
Oh,
Kubernetes level, or are we trying to talk about?
we eventually got to the point where we realized we could do it for bare metal servers, VMs, or pretty much
Okay.
anything.
Okay.
So that's part of why we talk about these things as workloads and not as pods, is because
Mm-hmm.
your workload could be a pod, it could be a VM, it could be some giant Oracle server running up in your data center. Um,
Mm-hmm.
and there's no reason that those workloads should know anything about where their peers are running, right? It's not really their
Yeah.
concern. Just like
Mm-hmm.
when you write an application, you don't really want to care about the cluster you're running on. You want to run your application and deploy it. Well, you also really
Mm-hmm.
don't want to care about how the communications work under the covers.
Mm-hmm.
Um,
Yeah.
you just want them to work. It was sort
Yeah.
of an interesting observation
Well,
because if you look at what happened in cloud native with Kubernetes, a lot of what it did is it let you divorce your workload from the server it's running on. You write your pod, it gets deployed on some server, but you don't care which server, you don't care how that
Yeah.
magic happens.
Yeah.
But a funny thing happened with cloud native in that we decoupled the compute side, the runtime, but then we strongly coupled a particular single choice of networking, which was the Kubernetes
Yeah.
networking to every workload. And that seemed strange. And so Network Service Mesh just says, look, you still get whatever your native networking is, which in Kubernetes case is what your CNI plugin provides. We're not going to mess with that. It works. It's great. But we will let you also connect individual workloads to whatever other network service they need, whatever other connectivity to other workloads they need. And that ends up being very powerful. Because you may have situations where you have multiple different parties your workload needs to communicate with who don't even know about each other. They're mutually ignorant. And so you can't get one single communication domain that you talk over to both of them. So you have to sort of plug into them individually.
Okay. Okay, so one more problem I feel like I want to capture, which I can't quite, I need your help getting the right words. But you were talking about how there's a need in Kubernetes for like a telecommunications company to work at layer 3 and layer 7 at the same time or something.
Well,
That's what I want
the
to
layer
capture.
7 for the layer 7 stuff, we've got lots of good tools in Kubernetes that you can work with. Service application
Okay.
service meshes, services, etc. It really is when you're to the point where you're processing packets or Ethernet frames or that kind of lower level thing with networks as a network service where you didn't have good answers in Kubernetes. And so we often think about it as sort of two sets of use cases, two sets of user problems. One is for telecommunications companies. The other is for enterprises. And the enterprise use cases were things that we noticed we could solve a little after the beginning. So it wasn't originally where we were starting. It was the realization that, oh, wait, we can sort of solve these problems pretty easily too.
So is one problem, is this accurate? Telecommunication companies want to process at the L3 layer.
And also sometimes at L2. Which we'll also let them do. We'll also let them carry Ethernet frames as payload if they want to. Enterprise use cases almost never want to do that, but it turns out that telecoms do, and I'm sure they have perfectly lovely reasons why they want to do that, and it's none of our business. So we just
right on. All right, so I feel like I've captured the problems and you've kind of talked about what network service mesh does, but I'd like to be a little more deliberate and untangle it. Let's start, if it's okay with you, I would love to start with like a definition of network service mesh. Does it feel like the right time for that? Okay.
That's absolutely fine, right? So probably a good place to start there is to start with the definition of a network service.
Okay.
Right. So a network service is just something that processes either, and let's just talk about IP packets for the moment because the Ethernet frames we can also do, but IP packets are easier to talk about. Something that provides connectivity, security, and observability by processing IP packets. So whatever your workload is, you go and you open an HTTP connection to something that gets turned by the network stack into packets. And if those packets go out to a network service, it may be doing something like, routing them to all the other databases that you're connected to for wherever they may be. For connectivity, it may be doing something like providing intrusion protection in front of that communication. It could be providing some level of observability with regard to the actual traffic itself at layer 3, not just at layer 7. And so that's effectively it. Anything that accepts packets and does something with them can be thought of as a network service.
Okay. We have We have a Cisco related question. Is that something you want to take, or would you like
I
to punt it?
I have not been cleared to make product comments on these
Okay,
matters.
that's
I apologize.
yeah. Sorry about that.
I have lovely minders who I have long cultivated relationships with that primarily consist of the fact that I don't make an ass of myself in public about certain topics. Um,
So it accepts IP packets and does something with it.
yeah, I make sure they get to somebody. I do some sort of security dance with them. Um, those sorts of things.
Cool. So a network
Just like
service.
just like when you
Okay.
by analogy, when you think of an application service mesh and what they mean by services, what they generally
Hmm.
mean is there's somebody there, usually an HTTP endpoint, that if I send them an HTTP message, they will do something with it. They will process it and mutate the world, and they will send me a response and that kind of thing. So a network service is in that sense directly analogous to a traditional service in Kubernetes or in application service mesh.
Okay. That was a hard thing when I was just getting started, was the word service is used everywhere for a lot of
Oh, and
things. I really like
it's horrifically abused, and I cannot tell you how many hours I have spent in conference rooms trying to dissuade people of their overloading of the term service, in
yeah.
ways that are unhelpful. Um, but
So we
one of the
got an
fundamental things about both traditional services and network services is it's the abstract notion of what you want. It's not the concrete thing that does it. Does that make sense?
oh, so the any service, a service in almost any context is an abstract notion of what you want as opposed to a concrete thing that does it.
Right. So if you take a look at Kubernetes services, and the same thing
Uh-huh.
projects forward in traditional application service mesh. If I'm talking about a service, right, you're saying, okay, this is the service I would like. But in the background,
Yeah. Yeah,
some
the
number
workload
of
pod.
you have some number of what they call endpoints, which
Uh-huh.
actually provide that service, and they just make sure to connect you to one of those endpoints.
Ah, that's helpful. That's
And
very
and
helpful.
absolutely. So, and network service mesh is no different in that sense, in that we have this abstract notion of a network service. And so when your workload comes up, and we will usually call the workloads that are asking for some network service, creatively, we've termed them network service clients.
Yes,
Uh,
yes, yes.
when they come up and they want to be connected to a network service mesh will find a network service endpoint that provides the network service they want, and we will facilitate stringing what we call a virtual wire or a vWire between your workload and whatever it is that's providing that network service, wherever it may be. And so that virtual wire in your pod will usually show up as an additional kernel interface. Um, and then, some routes that route
Interesting.
traffic to it and stuff. And so when you go and do something where you're like, okay, now I want to go talk, you talk the way you normally do. But if that
Uh-huh.
traffic is supposed to be handled by your network service, it gets routed out that interface and across the virtual wire to a network service endpoint that does whatever the thing is.
Okay. So what mm, I don't the idea of a new kernel interface is something I've never encountered before. Does that just mean
Oh,
like you can make different syscalls? Like there's like now new syscalls you can make?
not quite. So but this is a really good
Okay.
thing to drill into. Um, so basically, think of it this way. When you were talking about traditional Kubernetes networking, did they talk
Mm-hmm.
to you about how you will get a kernel interface that shows up in your pod? It's often ETH0.
No.
Ah, okay.
Uh no. A kernel interface in my pod in Kubernetes? Mm-mm, that's not familiar.
Okay. So if you sit on any Linux box that has network connectivity, and
Mm-hmm.
you either use the old ifconfig command, which will show you all the network interfaces in the boxes from the kernel's point of view, or
Uh-huh.
the new version is something called IP route 2, and you just say something like IP link. It will show you a link of
Uh,
all the network interfaces in the box. And those network interfaces
ah.
will traditionally all have information like this is my MAC address, and this is any IP address that's been assigned to me,
Ah.
and that kind of
So
stuff.
this one Linux kernel knows about all the other machines it's connected to, and then
Well,
that's called a network
the
interface.
well, the
What do
kernel
you?
has a sense of one end of think of it as having one end of a pipe,
Uh-huh.
right? So I have one end of a pipe, and
Uh-huh.
if you start with something simple like if you have a Python script where you want to connect to an HTTP URL, right? So it's
Uh-huh.
http://example.com/foo, right?
Uh-huh.
So what happens there? Um, Somewhere deep in the bowels of your Python library,
Uh-huh.
something says, I would like a TCP connection to example.com.
Uh-huh.
Now, under the covers, someone in the stack does a DNS lookup to get the IP address for example.com,
Yep.
and then they open a TCP connection to it. The
Yep.
underlying calls to the kernel that open that TCP connection just say, please give me a TCP connection to, 8.8.8.8 port something.
Uh-huh.
The kernel looks at that IP address and basically says, okay, what pipe do I shove that packet out of? And the way it
Uh-huh.
decides which pipe to shove that packet out of is it looks at what's called its routing table. The routing table basically
Ah.
says, in most cases, the routing table just says, dude, I've only got one pipe, shove it out that one. But you can have multiple of these pipes, multiple of these interfaces in Linux. And it may be that all the traffic that's going to 1.0.0.0 and all the things under it goes out pipe A, ETH0, and everything that's going to go out that is destined for 8.8.0.0, right, and all the other things like that goes out, interface ETH1, and then anything else goes out interface ETH2, right? So you have some notion that the kernel has of how to figure this out. You as the application developer don't have to think about any of this because it's annoying, and we don't like to annoy application developers.
So I'm a Linux kernel, and I'm holding lots of pipes, and my pipes lead to different places that I figured out, and it's the IP table where I know what pipes I'm holding. What about when someone far away connects to me? Is that a new pipe too that goes on my IP table?
Not at the level of interfaces. Not at the level of interfaces.
Okay.
So there's this very old, oft maligned television scene you may have seen go by from probably 10 years ago, where some truly clueless senator from I think the state of Alaska makes some statement that he was derided for, that the internet is a series of tubes. And that statement is both dreadfully ill-informed, but also completely accurate. And it's different tubes at different layers when you talk about the OSI stack. So when you're talking down at the level of something like layer 2 or layer 2, what you're really talking about is basically something you shove packets into down this pipe and they get places. But there's also an abstract concept up at TCP that you can also think of as a pipe that you just shove bytes into and they come out somewhere else. And in between, you have the network, which is sort of my historical stock and trade, where all kinds of magic happens so that if someone sends you stuff, they have figured out a pipe on their server to stick the packet into. The network in between, which you can think of sort of as a network service, solves the complicated problem of making sure that the packet that went out in their pipe is the packet that then arrives on the correct pipe on your machine, that gets picked up, written up the stack, and shoved into the right TCP connection.
Yeah. I'm with you, surprisingly. Yeah.
Which is why the internet is a series of tubes. It's hysterical because it's both incredibly naive and actually also completely accurate.
So in terms of our purpose for being here and writing on the board, which of that, it's tubes all the way down, says eventually.
No, totally right. It is tubes all the way down. Well, basically yes.
How much of that IP table story do you think it's important to capture here, if any?
None at this part of understanding. Then we may get to a place later where it becomes more important to reintroduce some of that story. But at this stage, it would be too much minutia all at once. I sort of went on that particular tangent because you asked. And I think like the
Okay.
conversation was interesting and helpful, but I have no idea how to
That's
make sense
fun.
of that without completely derailing the broader picture. And since you're trying to bring coherent order on the board, it's not going to be helpful.
It was a wonderful detour, though. I enjoyed every second of it. So then, getting back on the road, the road we're on right now. The next thing we need to say is, what is network service mesh? We said what a network service is now, and now what is network service mesh?
So network service mesh is basically something that connects individual workloads to 0 or more network services that they want to be able to utilize to communicate with other workloads.
Can we call it a technology instead of something?
I
Is
mean,
that accurate?
technology is absolutely accurate. I think we should probably definitely not use the pluralism of calling it a blessed thingy. But
Okay, it's a technology that say it again, please. I got distracted.
that's okay. The network
Write
service
it
mesh
down.
technology is a technology that allows workloads to connect to 0 or more network services.
A 0 or more. So
Well, it is truly 0 or more because we don't screw around with the Kubernetes networking because that would be a terrible idea.
okay. Oh, questions.
Mhm.
If you don't screw around with Kubernetes networking, does that mean you don't work with it doesn't work with Kubernetes? Or it's still
So we are slightly so we do work with Kubernetes, but we're slightly orthogonal to Kubernetes, meaning that because we realize it turns out it's very complicated to do things that are not Kubernetes networking without breaking Kubernetes networking. And so we
okay.
take great pains not to break it, but that also means
Uh-huh.
that Kubernetes, we don't have to have Kubernetes be aware of all the shenanigans we're pulling off because the
Uh-huh.
semantics of the network services, they can be all over the place, right? You can almost think of Kubernetes networking as having that one particular semantics we talked about at the beginning, where it's like, okay, you've got IP connectivity, you've got isolation, you've got services. That's a set of semantics where you talk about, what networking you get. But there are a million others. There's no end of creativity. The IETF has been at this for 40 years now as to the kinds of semantics you would like for your networking. And a network service can provide any kind of semantics that you want, right? It can give you pure
Okay.
IP connectivity and nothing that looks like services at all. It can do all kinds of weird things. We don't want to have Kubernetes carry the descriptions for all of that because then
Okay.
Kubernetes gets to be unnecessarily complicated for common users, and that's not a desirable thing. Kubernetes is complicated enough. You don't want to make it harder for the common user. All we do is come in and say, look, you don't have to tell us how any of this works. You just have to say, someone is providing a network service to me on the network service mesh, and I want to connect to that by name. Please connect me to that by
Okay.
name, and we will do that for you.
Okay. So the user experience is someone wants me to connect to a certain network service mesh, and I know the
Yeah,
name of it, and
it's
I connect
literally
to it.
a one-line annotation that you add to your pod that essentially says,
Mm-hmm.
"Hey, um,
See,
please
now we're talking
connect
about
me
Kubernetes
to."
again.
No, I understand. It's
Okay.
easy. The thing is, one of the nice things about Kubernetes that's underappreciated is it gives you an easy enough rubric to talk about things.
Yeah.
And so if
Yeah.
you were in the context of Kubernetes and the workloads you're
Okay.
deploying as a pod, then you just basically added a single line annotation that says, here's the list of the names of the network services I want to be connected to, in addition
Mm-hmm.
to my default Kubernetes networking, which is going to continue to work the way I'm used to it working.
Okay. To a Kubernetes pod, for example,
Yep.
that says that names the
Mhm.
network service by that they want to
Yep,
connect to by name. Hmm.
exactly.
Cool. Um, I'm scratching around the edges of what's happening. It's still not quite sinking in like I wanted to. But one thing that is confusing for me,
Mhm.
I think, is like, where is it? Where's it running? Or networks don't really run.
No, this is a great question. And so the best conversations are the one where it looks like you've paid somebody to be a straight man for you, which is kind of where we're at right now. Because the the we talked about what a network service mesh as an abstract thing, and we've talked about what it does for the user, and that you can basically
Mhm.
ask to be connected to this network service. But you're right, we
Mhm.
haven't said anything about where the hell this network service is and where it's running. And
Yeah.
that's somewhat intentional, actually, because
Mm.
the user never has to know or care where the network service is coming from. And network
Okay.
service mesh is designed in such a way that the thing that's providing that network service, which is, we call this a network service endpoint, could be another pod running in your cluster or some other cluster that processes packets. It could be a
Okay.
VM that's running somewhere. It could be a server that's running somewhere. Or
Mhm.
it could even be a piece of physical hardware, network hardware equipment that is running somewhere that we are plugging you into. Um, the reintroduction of the blessed thingy. Um,
And
I
it's
don't know how many
providing.
people I don't know how many people on these days still remember reading Larry Wall and wondering how much pot he'd been smoking when he wrote that book. But
Uh,
for Pearl,
I'm okay. I'm unfamiliar with the book. I just like the term "blessed thingy." Uh, could be. Okay, will you go through that list for me again of things that could be blessed
it could be
thingy possibilities? Okay, wait.
it could be a pod either running in the
Uh-huh.
same cluster or a different cluster that processes packets, right?
Okay. 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 I'll just that's enough. Okay.
And as a quick side note, Marcello has a complicated question we will get to in a second. So we're here for you, Marcello. Um,
Awesome. Thank you for
it,
your question.
yes, no, it's a very good question. It's just, we'll get there in a second. Um,
Okay.
it could be a VM or another kind of server that processes packets.
Okay. VM or physical server.
Yep.
Okay.
It could even be the sort of physical routers and switches that you normally use to build a network. Could be the network service endpoints that are providing the service.
Ah. Is that L2 or L what?
It could be
L2.
L2 or L3. There are
Okay.
lots of different ways that you could connect to them, some of which are very interesting to some subpopulations. Um, but we won't go quite off into that particular tangent just yet. Um, so so effectively the client has no idea what the network service endpoint is, and in some sense network service
Mhm.
mesh doesn't either, because all we know
Mhm.
is that somebody has registered in our network service registry saying, hey, I provide a network service that has this name, and this is how you can reach out to me if you'd like me to handle my end of setting up a virtual wire to connect a workload to it.
Mhm.
So there's a lot of modularity here because we don't have to understand everything and we don't have to control everything, which is important. This is one of the things where SDN or software defined networking got into trouble, was that it worked great as long as you had dictatorial control over everything involved, but it didn't
Yeah.
play nicely with others so much.
And it's not
Um,
really safe either when you need to know everything. You don't. It just
it tends to be fragile. Um,
yeah.
I often will say that omniscience doesn't scale. because it doesn't. But there's a really deep-seated human desire to build systems that need to know everything and that need to control everything.
I think outside of tech, just there's a deep human desire just to have knowledge and control about everything in your life, you know? I
Yeah,
don't think it's
but when you think
specific
about it,
to
all the most
networking.
fun things fall outside. All the most fun things fall
Exactly.
outside of that particular envelope of the things that you actually control. I'm not nearly as interesting as the rest of my life, right? The parts that I don't
Yeah.
control and that I don't really know what's going on in.
Exactly. Should we thank you for your comments? Michael says, great
Oh, Michael, good to
conversation.
see you. It's been many, many years. Old friend of mine. So
Oh, awesome. Cool. Should we tackle Marcella's question?
yeah, let's tack over really quickly. Let me see if this is a good time to look at Marcelo's question. What are the resource types you need to find to create a network service and an NSM, e.g. for L7 services, you need services, ingress, etc. I especially expect CRDs are needed here, as well as a special type of software running inside the pods that implement DNS. Oh, wow. So you stacked a bunch of really pertinent questions there, Marcelo. So let me break this down bit by bit. So one thing to understand about service meshes in general is that very often at the root of them, what you have is a registry, where you can register the abstract services that are on offer, right? So if to take the simplest example, if you look at Kubernetes, you can go have a service CRD for classical services in Kubernetes. And then if you look at also at what Kubernetes does, we also have an endpoint registry where someone that provides those services can be enumerated as an endpoint for that particular kind of service. And those two things together in the most basic sense, services and endpoints, are kind of the stock in trade of any kind of service mesh that you're dealing with. Now in Kubernetes, the most basic versions show up as CRDs. There's lots of other fancy decorations for some related things that other service meshes will do as CRDs. Network service mesh is not so dissimilar in that we have a notion of a network service registry where people can register the kinds of network services that are on offer as abstract things, so the network services, and where network service endpoints that provide those network services can register as providing them to the registry. And there's a whole bunch of complicated auth with Spiffy and
And
Spire underneath that we won't go into just at this stage in the story.
okay.
Needless to say, there's a lot of security under the covers, so that it's just not any old person anywhere registering.
But
So
it sounds like that would aid in service discovery then too. Is
its
that
entire point
something?
is to allow service discovery by
Okay.
primarily by network service mesh infrastructure itself, but other people can as well for certain purposes.
Okay.
So what's different here about the way that you usually see this in Kubernetes, everyone talks about it in terms of CRDs in Kubernetes, is that network service mesh actually has a gRPC-based registry API where you can register the services and where the network service endpoints can register themselves as providing services. The reason we did this at the fundamental level as a gRPC API is we didn't want to be welded to a single cluster. That
Mm.
said, we do have a service registry that's very commonly used that uses the Kubernetes API server as a backing store, which means that if you're using that particular service registry, then these will show up visibly in Kubernetes as CRDs. So if you want to go kube control a network service or a network service endpoint, if you're using that backing store, you can do that because it's a really friendly way to interact with the system. But if you weld yourself to CRDs as the fundamental thing, then you wind up stuck in a single cluster world. And we didn't want to be stuck in that place. Let me see if I've drifted too far off. Did that start to answer the first part of your question, Marcella?
I think there's quite a lag, so we'll see if I think it's like
We'll
10
see if he
seconds
comes
or
back
something.
around.
Yeah.
The second part of his question about as what type of software running inside the pods that implement the network service. the things that implement the network service for enterprise kinds of applications, the things that you and I and most application authors will write, those applications don't actually have to know that network service mesh is there or doing anything. You don't run any magic special software. Now, on the telecom side, where you're doing all kinds of bizarro stuff, you have the ability to have special software that interacts with network service mesh in a more sophisticated way. But your common application developer just wants to be statically connected to a network service. So you add your annotation. We have a web admissions controller that will inject an init container that does all the messaging to set everything up. And by the time your workload is running, everything is already wired and plumbed together, and you don't have to think about it.
Something I don't understand, and I maybe should have understood it from the beginning, but something I don't understand right now is why your common application developer wants to use network service mesh as opposed, like, why is the L7 Kubernetes stuff not sufficient?
Well, so
for
on
that
the
particular
enterprise side,
developer?
yeah, on the enterprise side, think of it this way, right? Say,
Uh-huh.
let's take a very simple example having to do with database replication, right? So I have
Uh-huh.
some master database sitting far away, and I would like to
Uh-huh.
have read replicas of that database that run where I've got at least one read replica in every cluster. And I've got clusters in
Okay.
EKS and GKE and Azure, and I need to make sure that all those databases can talk to each other securely
Okay.
in order to do
Mhm.
database replication. But the databases
Mhm.
will tend to use funky protocols that are not handled by L7 service meshes particularly well, that just run over
Okay.
IP. And so
Okay.
I could basically say, I'll put an annotation on my read replica database
Mhm.
that I launch in my cluster that says, I want to connect to the database replication network service.
Okay.
And
Yep.
magic happens. And when it comes up and
Magic.
says, hey, I'd like to connect to the primary database so that I can do read replication for it, then the DNS magically resolves to the IP address of the primary database, which may not even, which may not even be reachable by that IP address over the general networking between us, but we've set up the network service. That resolves to an IP address. The connection gets put up at the level of something like TCP or UDP, and they
Uh-huh.
talk their funky protocol that we don't understand, and the database
Uh-huh.
replication happens. And the only things that have been admitted to that network service at all are the databases that are doing replication. So you've got a
Uh-huh.
tight set of things you're looking at. You can do
Yep.
observability for them. You can do heightened security logging that's specialized to
Yep.
database replication. None of the people writing applications have to worry about what clusters they're in and how to
Uh-huh.
set up complicated behaviors between them. Um,
Okay.
it just works is the
Yeah.
underlying piece of it.
And you don't have to connect the entire clusters. You don't nobody has to know too much about anything.
Well,
I'm
and
with
connecting
you.
entire clusters is really complicated because often
Uh-huh.
the IP address ranges that you're using in the clusters overlap.
Yeah.
And
Uh-huh.
so if I'm sitting in cluster A and I try and connect to 2.3.4.5, it may route me
Uh-huh.
to a pod in cluster A, but that's also the IP address in cluster B of the thing I actually wanted to talk to.
Uh-huh.
And so you wind up with all kinds of complications that could ensue trying to resolve these overlapping issues. And it's just simpler to reason about things in terms of these simple communication domains where you as the application developer just have to know which communication domains you need to be connected with. I mean, one of the other places that we see some of this is in what I'll sometimes call cross-organizational or cross-corporate domains. If I've got a
Mhm.
workload, like let's say that I'm a major automotive manufacturer and I've got thousands
Mhm.
of part suppliers, and
Mhm.
I stand up a network service where my part suppliers can talk to me and talk to each other.
Mhm.
They can connect to that. And I could have a workload as a part supplier that connects to that automotive manufacturer's
Mm.
network service, but it may also connect to a network service from my engineering group. And it may have a third network
Mhm.
service that's being provided by my supply chain group that it's connecting to. And I don't have to get my supply chain group and my manufacturing group and the auto manufacturer all to agree on a whole host of things because it all comes back to the individual workload connectivity. It's not trying to get all
Mm-hmm.
those organizations to communicate, which is a very hard problem. It's just trying to get this
Yeah.
one little workload to be able to communicate with each of those organizations. And there's a host of technical problems under the covers that get phenomenally easier when you
Mm-hmm.
do that than if you're trying to connect big chunky networks together.
It connects workloads, not systems. Is that accurate?
Yeah, it basically it connects workloads to network services. Now, a network
Yeah,
service may
yeah.
connect many workloads together, but I'm not saying
Uh-huh.
take all of cluster A and plug it into my network
Yeah.
service, right?
Yeah.
There are people who have done things where they've tried to say, "Oh, I'm going to connect cluster A to cluster B," but then you've got a host of
Mm-hmm.
things to resolve around. Okay, so in cluster A, I've got some isolation rules. How then do I apply them to traffic coming from cluster B? Or I've
Mm-hmm.
got services in cluster B. How then do I make sure that they're automatically doing the right thing for workloads that are trying to communicate to them from cluster A? And then how do I keep, as the number of clusters goes up and I've got to mirror all this data between all the clusters, how do I keep
Mm-hmm.
all of that synchronized in a timely manner? And one of the things that's really fascinating about Kubernetes as a system is Kubernetes is extremely well designed as a
Mm-hmm.
medium scale system. Kubernetes is not a large scale system, it's a medium scale system. And the people who designed it were brilliant, and they made a lot of very conscious trade offs, the result of which is it's kind of the largest medium scale system you can build given those trade offs. They
Uh-huh.
pushed it all the way to the wall. And
Uh-huh.
so when people start trying to mush many clusters together, you're taking the largest sort of things that you could build with those trade offs, and you're mushing them together and getting something bigger than really works well with those trade offs. Um, so yeah, no, I mean, I'm as you probably noticed, I'm a huge fan of a lot of the design stuff that went into Kubernetes, but you just have to
Yeah.
understand, like, all of life is trade offs, all of it.
Yeah. Uh-huh. So use cases for NSM. Connecting inter-organizational services. So you used a car part supplier with the car sales company. Connect multi-cloud apps to, say, a database that uses a funky protocol. Is
Well,
that
there's also a similar
oversimplifying? Yeah.
that's perfectly lovely, but there's also
Okay.
something where you can actually use network service mesh together with application service mesh, right? Because application service
Okay.
mesh does lots of interesting things for HTTP messages. But if I want to have a application service mesh, a traditional service mesh that
Mm-hmm.
spans a bunch of different clusters and a bunch of other different on-prem things, you start building up this large space of gateways that are effectively trying to do routing based on HTTP headers, and that gets very complicated. And so one of
Mm-hmm.
the things you could do with network service mesh is say, look, rather than having the complicated set of gateways, we'll run
Mm-hmm.
a very simple underlying network service that just does routing of IP packets and DNS. And then we will run an application service mesh, a single simple application service mesh on top of it. So it's no more
Mm-hmm.
complicated than running a service mesh for a single cluster, except that workloads from different clusters can connect in at the lower level to that network service. And so you get this very simple to reason about L7 service mesh that runs, application service mesh running on top of a network service mesh. Um, and it also has some other benefits in that every time you go through a layer 7 gateway, you have to go do an expensive set of processing because it turns out that it's really expensive to process HTTP messages compared to processing packets. Like, we literally built the protocols for
Oh.
packets so they could be processed very fast.
Uh-huh.
I mean, to give you some idea, one of the technologies that we use for processing packets in network service mesh is called VPP, and it will merrily process terabytes per second of traffic, of IPsec traffic on commodity servers. Even the very best HTTP proxies are glacially slow by comparison. Not because they're slow, but because they're doing a harder thing. They've got to parse text instead of looking at
Uh-huh.
fixed byte fields in a packet header.
Okay. I follow. Is there any, so we have for use cases, are there any that you want to add
On
that
the
maybe the
enterprise,
telecommunications one? Yeah.
Right. So, I mean, we can also add sort of like the telecommunications one, where what you really are doing is deploying a system of things that process packets.
Mm-hmm.
Um, but you've captured a bunch of the ones that you have for the enterprise side. Um,
So,
and mostly we think about these as telecom companies. It does turn out that there are enterprises that have problems that are sort of shaped similarly for large enterprises, but mostly it's easier to reason about for telecommunications companies.
cool. I have a question about. So I've been learning a lot about these more traditional L7 service meshes, but
Hmm.
after spending, I think literally all of them say they both do L7 and L4, which we haven't even talked about yet.
Yeah,
What does,
L4 sort of
how does,
lives in the middle. Yeah. Mhm.
yeah, how does L4, I guess we should like rephrase what it is, which is the routing layer, they'll call it, as opposed to the application layer,
Not
which is
not
where
not
like,
quite. It's L4 is typically the transport layer. So it's protocols
okay,
like TCP that give you what
uh-huh,
looks more or less like a pipe for bytes. And essentially think of it
okay,
as taking something that thinks it's going to one IP address and port number and connecting it over to something that is um, basically a different IP address and port number, and possibly going and looking at what's going on with the bytes in between. Um, but the thing that gets complicated about that is that you've got to figure out what, if anything, you're going to do. So if you just are cross connecting those byte streams, you can do that with the
uh-huh,
traditional service meshes. But then you've got to
uh-huh,
figure out what's going on in the bytes in between, and you're back to the place of processing higher up the layer stack, which is more
uh-huh,
expensive than just moving the packets around from a performance point of view. So all of them in principle support L4, but the number of people doing a lot with L4 tends to be much lower than with the L7 stuff. And many of the more
okay,
sophisticated features are coming from the L7 sort of stuff. When people are saying things about routing HTTP messages, or inserting spiffy IDs into things, or tracing tags, or all the rest of that stuff. There's a lot fewer things that are doing non-HTTP things at L4 with them. Does that make sense?
I think so. In my mind, I had L4. Is L4 like MTLS? Where's that
Um,
today?
so now we move into the world where people can become pedantic. Um,
Okay.
which is to say that there are technically 7 layers in the OSI model. There are these
Uh-huh.
two red-headed stepchildren called layer 5 and layer 6, which are
Okay.
basically presentation layer and session layer, and we
Uh-huh.
mostly just ignore them. Um, and But the truth of the matter is, things like MTLS encryption live in those layers. I
Okay.
think it lives at the presentation layer technically, but nobody
Uh-huh.
really thinks about it that way. And it's because when we built the internet to
Uh-huh.
begin with, we only really did the first 4 layers, right? Up through
Uh-huh.
TCP. People often used to talk about it as
Okay.
TCP/IP, and then you had
Okay.
things that sprung up further up called like HTTP, and we just called those L7. They're
Mm-hmm.
application protocols, and so you if you wish to be pedantic, you can absolutely say MTLS does not live at layer 4, but a lot of people think of it
Mm-hmm.
that way. Um,
Okay.
even though it's not pedantically correct, a lot of people will think
Okay.
about it that way.
Okay. Okay. And then L4 doesn't have anything to do with network service mesh because network service mesh is moving around packets below TCP.
For the most part, no. Although we do have some folks who are exploring doing some acceleration kinds of things where we will let you use faster TCP stacks. There's a whole bunch of what we call exotics that are available in network service mesh for people who have
Mm-hmm.
more demanding needs from their networking than they can get from the Linux kernel. And we
Mm-hmm.
have some people playing at L4 there, but it's not a huge headline use case at this stage, or rather, the amount of explanation involved would be extreme. and probably not interesting to most listeners, unless they have those particular like if you have those problems, it's fascinating, and if you don't have those problems, it can be a bit much.
Awesome. So where's a good place to take it from here?
Um,
So it's running anywhere, somewhere. Don't even worry about it.
well, if you're a user, don't worry about it. I mean,
I guess
effectively,
that's a question then. Is like, okay, I'm not a user. I'm setting this up. How much work is it for me? Like,
um,
what's the setup process like?
it's like any other reasonably good Kubernetes related thing. If you're doing it, if you're trying
Uh-huh.
to enable a pod, which is
Mm-hmm.
you kube control apply -k a
Mm-hmm.
file, and it will
Uh-huh.
go and it will run the appropriate pieces for network service mesh in your cluster. And now,
Uh-huh.
congratulations, you are network service mesh enabled, and people can add the annotations to their pods and connect to network services, or you could deploy pods that provide network services. Um, and then you've got a bunch of questions about security policy related things for who's allowed to play with you that you can stick in there as well. So it's a very
Okay.
simple setup in that regard. Um, there's lots of interesting sort of, depending on where your interests lie, minutia about how things work under the covers. That
Uh-huh.
depending on where, and this is sort of a question for the chat, which is what kinds of things is the chat interested in? Do we have people who are interested in what's happening under the covers? Do we have folks who are, who have other sorts of interests? Are you interested in what this actually looks like inside your pod, for example, which could be interesting? Are you interested
Mm-hmm.
in what things get deployed? Um, we could also talk about things like sort of how this gets into other environments. Um, you know,
What what about like if I want to set up an inter-organizational service, if they're both running
mhm,
Kubernetes, they both do their apply-k command, and then we just agree on some networking
mhm.
names. Okay.
Yeah.
And if
So
we're
typically,
what if yeah.
go ahead. No, please go ahead.
Oh, I was gonna say, what if it's the database situation where now we're using different protocols and we're using the databases outside of Kubernetes in its own place?
Yeah. So network service mesh has this
Uh-huh.
concept. We talked about having a network service registry. And
Uh-huh.
so we have
Okay,
this
yeah.
concept of a network service registry domain, which is literally just, um, if I'm example.com and somebody else is foo.bar, foo.com,
Uh-huh.
right? We might both set up network service registry domains for our network services. And so I could
Okay.
say something like, for whatever reason, foo.com needs to be able to participate in my database replication network service from example.com. So they would simply say, I need database dash replication at example.com as the name of
Uh-huh.
their network service they want to connect to. Everything after the at
Okay.
refers to the domain. And then
Mm-hmm.
presuming that I have configured things so that they are allowed to query my registry, they
Mm-hmm.
could basically attempt to, the network service mesh running in their cluster could attempt to establish a virtual wire to some endpoint that I have that is providing that
Mm-hmm.
network service.
Cool.
And presuming that I am willing to allow them to connect to that network service, which is a different authorization question than whether I'm willing to let them look at my registry, um,
Yeah.
then we can string up a virtual wire that on their end in their pod looks like a network interface, right? With
Mm-hmm.
all the normal sort of behavior. So when they go look up the primary DB dot, you know, replication domain dot example.com, it resolves to an IP address that gets routed over that virtual wire to my network service, and everything works. Um, and away we go. And one of the nice things about this is network service mesh was really designed to work at internet scale. So it really is a question of authorization. It's not a
Mm-hmm.
question of having to get us all to agree on a complicated set of things that we don't necessarily want to have to go negotiate. Because when you do this in a traditional sense, let's say that I'm example.com and instead I want to do this the old fashioned way, and I want to string
Mm-hmm.
a VPN connection from your entire cluster to my network. Now I've got a complicated set of negotiations where we have to get our IP addresses not to overlap
Mhm.
correctly, and I've got to put up a bunch of complicated firewall rules to try and decide what
Mhm.
you're allowed to talk to in my network and all the rest of that stuff.
Oh.
And if you
Yeah.
talk to customers who have to do this, this can take multiple quarters per partner
Yeah.
that you're
And
dealing
it's
with.
tedious. Yeah. Uh-huh.
And with network service mesh, it's a matter of saying, okay, these are going to be my authorization rules for workloads from foo.com. I'm going
Yeah.
to put those authorization rules in, and then now
Uh-huh.
everything just clicks through, and in a couple seconds, everything is connected.
Okay. Amazing. How does network service mesh handle authentication and authorization?
So like anything else, anytime you're dealing with security, try not to reinvent the wheel because you're going to do it badly.
Yes,
Um,
100%. Yes.
and so we lean heavily on Spiffy and Spire because they do a
Okay.
really good job. I think you actually talked with them.
Yeah,
Um,
I did this last week, I think.
they they do a great job, and we've got a long and useful collaboration with them. We collaborated with them a lot about templating out workload identities because we had some needs that turned out to be needs that lots of people had, and we had some ideas about them, and they could not have been more lovely in that
Huh.
collaboration. Um, and and so effectively, all workloads in network service mesh get a Spiffy ID, and effectively you can use Spiffy federation. So if you're foo.com and I'm example.com, we can federate our identity services, which means now I can recognize your identities as valid identities. And
Mhm.
then you can use the information from that in order to decide that you are going to authorize or not authorize my workloads. And we also
Mhm.
do some interesting things around what I call transitive authentication. So we have
Mhm.
an interesting problem in network service mesh that lots of people have, but very few people acknowledge, which
Mm.
is that it's not just the endpoints that matter in the communication in terms of trust. There
Uh-huh.
may be things in the middle in network service mesh that are processing your network traffic, and you need to
Mhm.
decide whether you trust them as well. So if I'm a
Mhm.
workload, you may be willing to trust me as a workload, but
Mhm.
I may be passing through the hands of things in your cluster that you aren't
Mhm.
willing to trust, depending on the
Oh,
sensitivity of the service I'm trying to
sure.
connect to. And so we can
Yeah.
actually reason about all the hops that the virtual wire passes through, if you so choose, in terms of whether you authorize things to connect or not.
Mhm. I'm I'm going to tell you the preconceptions I had before and how
Oh,
I think
lovely.
they've changed, but it's so I understood that network service mesh uh provided connectivity between like your Kubernetes estate, your virtual machine estate, your
Mhm,
um bare metal estates. And so I didn't understand the value of it because I didn't understand about this L3. So in my mind, it's
mhm,
like, oh, well, that's even when I talk to Kuma, like Kuma's value proposition is there a universal mesh, and that you could use Kuma to connect these same three things I just
mhm,
described, your VMs estate to your Kubernetes. And so what I'm learning is I would like your opinion on like just what's different. But my understanding is that with Kuma, when you're connecting those things, it's more of an all or nothing situation. Like you're connecting this all the VMs that are connected to each other to all the Kubernetes. Like once you connect
mhm,
uh the greater clump of things, then the all the clumps are everything in each clump is connected, and you probably have to like similar to Kubernetes specifically say what can't talk. Um, and here we're talking about only connecting workloads to one another in each different
mhm.
place that's connected. And
Well,
I
only
could see
connecting
the va-
workloads
and
to network services that can connect them to one another. Yes.
yes,
So
yes.
it's at a finer grain, and it's also quite a bit less greedy. Um,
Uh-huh.
so
Yeah.
one of the things that you find with application service meshes, and greedy is perhaps too charged a word for it, because nobody
Uh-huh.
set out to be this way. But
Yeah.
if I'm a pod, I am connected to, at most, one service mesh, generally speaking, right?
Yeah.
There's no way
Yes.
for me to be connected to multiple service meshes.
Are we talking about, when we say that, are we talking about the application layer meshes?
Application
Yes,
service,
we are, because you
application
definitely
layer
talked about how.
meshes, right?
Uh-huh.
So an application service mesh, I can be connected to exactly one service mesh. And this
Yeah.
produces complications because effectively I then wind up having to deal with, when you talk about having a universal service mesh, it's like, okay, now I have one very large universal service mesh that all the things
Yeah.
and all the places have to connect to, and I have to manage that complexity between all the different
Uh-huh.
people who are using it. And in fact, while it's not strictly true that I can have only one service mesh per cluster, in practice, it's
Uh-huh.
true that my cluster has exactly one service mesh in most circumstances at the application
Yeah.
service mesh layer. Network
Uh-huh.
service mesh, by contrast, is non-greedy, meaning that
Uh-huh.
if I'm a workload, I can connect to multiple network services that don't know
Uh-huh.
anything about each other, including
Ah.
multiple network services that are running application service meshes on top of each other that don't know
Yeah.
anything about each other. I can
So,
also have different network services on offer in my cluster that are completely ignorant of each other. So
mm-hmm.
different styles of communication. I can even use network services that don't come from
Mm,
my organization, presuming I'm
mm-hmm.
authorized from both ends. And again, other than authorization, nobody has to know or understand anything. So the level of mutual ignorance that's available is pretty profound. And when you start getting into sort of the real world where everything is messy, that's very valuable.
Uh-huh. I think it would be interesting to get into, like, compare and contrast the network service mesh, like in terms of writing on the board with the other types of
Sure.
service meshes.
Mhm.
Um, I had something else. Oh, I don't know. Let's just do that. If you're game, I would love to do
Oh,
that.
absolutely. Right. So
Okay, cool.
it may be more useful to talk about application service meshes in the generic because they tend to
Okay.
be very, very similar in a lot of ways to one another, right?
Okay.
They're all trying to they're all trying to compete in roughly the same feature space. Um,
Okay.
and so probably the first place to differentiate is in terms of what kind of a payload they're reasoning about, right? Yeah,
Okay.
Istio, Kuma, Linkerd.
I think that's it. Not Cilium, because
Oh,
that's a whole
I'm.
different. Yeah.
Cilium has a service mesh, but they've got a lot of other stuff, and
Yeah.
they don't draw the lines as cleanly. So there'll be your
Okay.
service mesh and your CNI plugin,
Yeah. Yeah.
and also some security tooling that does things that may or may not be related to networking. And like they don't draw the lines crisply in the same places, although they will provide some of the similar functionality. So yeah, so I'm application service meshes are mostly operating at layer 7 and layer 4. So things like
Okay.
HTTP messages, and to a lesser extent, things like plugging TCP and UDP tubes together.
Okay. Will you say that really quickly again? Because we're saying it differently than we said it before. Oh, actually, I don't even have this on the board, which it should be on the board. So great. L7 is HTTP communications. Is that accurate?
It's going to be HTTP communications, yes. It's the
Uh-huh.
application protocols, and the one that most people are working with is HTTP. Um,
Would gRPC be at this layer?
yes, gRPC is sort of running on top of HTTP already.
Okay.
And when I say sort of, it's mostly running on top of HTTP2, but they've got some weird funkiness going on.
And then
So
L4 is
things like
TCP.
TCP and UDP,
Cool.
but it's basically just plugging those pipes together.
Cool.
Network service mesh, by contrast, network service mesh is operating primarily on payloads that are L3 IP packets, or for certain exotic use cases, other things like L2 Ethernet. But are the payloads that we're operating on. Now, there can also be other things riding on top of us. Like you can literally run an application service mesh on top of a network service. But NSM itself, starts handing off that problem when it's done moving packets around.
Okay. L3 usually.
Like IP packets. Yeah.
Mm-hmm. Yeah. Sometimes L2. Okay.
I'm very torn on L2 because most of the places that people use L2 in the cloud are a terrible idea, but not all of them. So like most of the time when I hear someone wanting to do something with L2, I cringe.
Uh-huh.
But there are some legitimate use cases, which is why we support it.
Right on.
Yeah. So, and that's sort of the payload piece, like the payloads that you're operating on is one big distinction.
Mm-hmm.
And then sort of another distinction that you might look at is sort of greediness in the sense that
Mm-hmm.
most application service meshes effectively you get no more than one for any given workload, and
Mm-hmm.
typically you don't get more than one for a cluster. And please note, I'm slightly hedging when I say that typically, because I know people close to some of these who will go mumble mumble, but namespaces, and they're not wrong in principle. I just have never seen anyone do that in the wild.
Okay.
I'm sure they exist.
One thing that seemed to, I think we talked about in the Kuma episode, was like having a different instance of Kuma. I've never heard of more than one instance of it in a single cluster, but like here's an instance for Kuma of this cluster, here's an instance of Kuma for this other cluster, and
You
then
know,
there's
gateways between them.
yeah, or there's like um, another instance of Kuma that is in charge of all the instances of Kuma.
Okay, so I'm not a super expert on Kuma, although I've had a little bit of
Okay.
exposure. And I've had enough exposure to enough service meshes I can make guesses as to what was
Uh-huh.
going on there, but I can't say for sure that
Uh-huh.
I'm right. In that
Uh-huh.
when you're dealing with application service meshes, they typically have
Uh-huh.
a control plane, and then they have a bunch of
Yeah.
proxies that are running. Like in the
Okay.
classic
Yeah.
example would be an HTTP proxy running in a sidecar pod,
Yeah. Yeah.
right?
Mm-hmm.
Although,
Yeah.
mumble, mumble, ambient mesh, mumble, mumble, different ways of doing it
Oh
now.
yeah. Uh-huh.
So I
Yeah.
don't mean to pigeonhole them. That's sort of the classic way you think about it. And the control
Uh-huh.
plane manages all the proxies to make sure that they're doing the right things. What they
Yeah.
might
Yeah.
have meant in Kuma is that you have a control plane running in cluster A and a control
Mm-hmm.
plane running in cluster B, and then some
Yep.
overarching control plane that is bouncing around both control planes.
But that is managing all the control planes and all the clusters. Yes.
Right. And that's probably is what they were talking about, because it's rational. It makes sense, right? They could be doing
Yeah.
something
Uh-huh.
super cool and creative that hasn't occurred to me, but the sort of
Uh-huh.
the logical thing you would expect them to be doing in that circumstance is kind of what I was describing.
Okay.
And in network service mesh sort of takes
Uh-huh.
a little bit of a different attitude in that we're non-greedy, in
Mm-hmm.
that, basically where they have, we're sort of like more peer-to-peer, if you will. So
Mm-hmm.
number one, individual workloads can connect to multiple network services, not just one. So traffic
Mm-hmm.
can go out to multiple network services. And not all of those network services have to be under the same administrative control, right? I could be
Oh, fascinating. Yeah.
right. I could be a pod in foo.com that is connecting to a
Mm-hmm.
network service that is being provided by example.com.
Mm-hmm.
Now, again, there's authorization protections to make sure this doesn't go off the rails in from a security
Mm-hmm.
point of view. But I don't have to micromanage getting those to match up from a networking point of view. I just have to make sure the
Mm-hmm.
authorization is present. And that actually is super helpful, because it turns out that we often talk about this about two different companies talking to each other. But anyone
Uh-huh.
who's been in a large company is aware of the fact that different departments or business units in the same company might as well be different companies as much as they talk to each
Yeah.
other. Um,
Yeah.
and so like I've had tons of conversations with people like Mumble, is the intercorporate use case really all that big? And I'm like, dude, have you talked to finance lately? Um,
Yeah. How can we bill if we're not going
well,
to
or, I
let
mean,
them do stuff on our
everybody's
dime?
got their own set of concerns. Like the finance guys in any
Mm-hmm.
company have a legitimate set of really serious concerns that are
Yeah.
quite different than, say, your engineering department or your
Uh-huh.
marketing department.
Mm-hmm.
And how those have been rectified over the history of your company, God only knows.
Mm-hmm.
And God help you if you acquire companies. Um, so
Uh-huh. Yeah.
and so the non-greediness ends up being actually a big deal. The fact that we can have mutually ignorant things coexist with each other
Mm-hmm.
from a connectivity point of view ends up being
Mm-hmm.
super helpful. Um, and that also means that it's easier to get things in different places talking to each other because with an
Uh-huh.
application service mesh, if I want applications in cluster A and cluster B that are running in different clouds to talk to each other, typically
Mm-hmm.
speaking, I have to set up and configure in a pairwise fashion the gateways between all of those things. And I
Mm-hmm.
have to have administrative control over the gateways for both of those things. And effectively, you
Mm-hmm.
usually wind up having to have a single entity having administrative control over both service meshes in both clusters.
Uh-huh.
And one of the things that I've seen in the wild is because, again, companies are large and vast, you get this corner of the company that has deployed Kuma, and that corner is deployed Istio, and a third one is deployed Linkerd.
Uh-huh.
And then actually it turns out there are four different folks who deploy Istio, but they're different Istios, and they don't get along, and they don't want to play nice together. And network service mesh, because we live a layer down, it turns out
Uh-huh.
there's not as much religion a layer down because
Uh-huh.
there's just not as much going on. It's like, did the packet get
Uh-huh.
there? Yes, the packet got there. Did DNS work? Yes, DNS worked. Okay, good, we're fine.
Uh-huh.
Um,
Yeah. And yeah, and we have Spiffy and Spire to make sure everything's trusted.
that's the plan. Yes.
Uh-huh.
The Spiffy Inspire stuff has been fun. I've watched over the years as it's faded into more and more places. Thank God.
Uh-huh.
Because the last thing we need is it's not a place where you need a Tower of Babel of 15 different ways of doing it. And the
Yeah.
Spiffy Inspire folks have done a tremendous job. So let's just all use that, please. Um,
That seems to be how things are going. Yeah.
yeah,
Cool.
I'm glad to see that. It doesn't always turn out that nicely, but I'm glad in that case it did.
Do we have more to say about NSM network service mesh being different from application meshes?
Um, One thing that is true about it, and this is a little bit of an extension of the non-gradiness, is it is internet scale in a way that application service meshes are not.
Uh, uh-huh.
Meaning that it's a side effect of the interdomainness of it all, in that I could literally have millions of network service registry domains out there, and
Mm-hmm.
and modulo authorization, any of them I'm
Mm-hmm.
authorized to use are available to me.
Mm-hmm.
I don't know of anybody who has application service mesh where you could have millions of clusters out there, all of which your application service mesh could correctly connect you to. Right? It's just a huge
Mm-hmm.
difference in being internet scale. Um,
So app meshes, like like for an app mesh, if even if just one workload needs to talk to one workload on the other cluster, like a whole gateway to the entire cluster has to be added, right?
Typically, part
Okay.
of what's happening, and part of where NSM can be helpful to application service mesh is that if
Mm-hmm.
your application service mesh doesn't have what they call a flat layer 3 under it. In other words, if I don't have the same consistent IP connectivity between two clusters, then I've got to stick some kind of a gateway in there.
Mm-hmm.
Whereas with NSM, if I'm running, I can run a flat layer 3 domain that all the workloads can connect to and run a single application service mesh on top of it in order to scale out. So NSM scales really well. Um,
At internet scale.
yep,
Is that
at
what you
internet
said?
scale. Yep.
I hadn't heard that term before that I remember. I like it.
Yep, we've got that. We've got a bunch of other sort of interesting features around like scale from zero and healing, and because the standard presumption anytime you're dealing with a cloud native environment is that everything is failing all the time, and so you got to be designed for
Yeah.
that.
Yeah.
And also, there's no difference between a failure and an upgrade; they're the same thing. Um, so
That's another one that I think might be true in life in general, actually.
now
For
that you mention
people.
it, no, there really isn't a lot of difference between a failure and an upgrade. They're kind of indistinguishable, and that sort of brings us back a little bit to where we started when I said that network service mesh came out of a crisis of success for Kubernetes networking, which was they'd done such a good job at solving. There's the old adage, I think it's from Linus, optimized for the average case, and they'd done such a good job of solving for the average case of what people wanted in intra-cluster networking that it made it hard to do other things.
Yeah.
And so that was, that I think it's the same thing with failure versus upgrade, right? If you're stuck in one particular set of things, you kind of have to fail at it so you can move on to the next set of things.
Yeah. Yeah. Well, we can, do you have something you want to put in this last bit of space? Or I can maybe start the recap, and in the recap we'll reveal questions and what to expound
That
upon.
might be a good idea. That might be a good idea. The chat has been a little bit quiet for a while. If folks in the chat have other questions, I would be delighted to answer those. There were some good ones that went by.
Sometimes what happens is at the top of the hour, people have to go to meetings or whatever, so some folks drop off.
That's completely normal.
Yeah. So do you feel, am I like frozen? Can you hear me?
There were a couple of, you're currently frozen, and there were a couple of glitches. Where like weird corners of the board got magnified and background inverted, and
that's exciting. And I'm still frozen, huh? Okay,
you're still frozen.
I'm just gonna pop off and back on and try to get my movement back. And
all right, try and be a little less stiff, and we'll talk for a second. And I'll try and see something interesting in the interim. Now you're a little glowing ball that's bouncing at me. So,
all right, let's disconnecting the camera and connecting it again and seeing if that makes it happy.
Yep. Oh, so Marcello had said something positive about the build the super system to control everything. Yeah, no, I've seen so many people make that mistake, and it's such a human mistake to want to try and control everything. But the truth of the matter is that there's such a significant limit in what we can understand. All the best systems are emergent. It's actually one of the things that's quite nice about Kubernetes is that, to a large degree, the things that work about Kubernetes are emergent phenomena. All the way down to sort of how things are architecturally. In some sense, the Kubernetes API server is sort of like a chalk, it's like a wall that we all scribble messages on. And in response to that, various entities do their own thing, and it ends up working out. But the human desire to try and make everything deterministic, so for sure it will work out in a particular way, is very strong.
I just restarted the whole Lightboard system, and now let's see if that. Aha. Da-da-da-da.
And I see, and you're moving. You have achieved motion.
I'm moving. It's a well-loved Lightboard. It gets a lot of attention, but sometimes it complains. All right. So we're gonna do a recap, and then we're gonna let the recap decide what we put in our final little bit of board.
Sure.
So this has been wonderful. I came from a place, I think maybe my understanding was negative, since I was a little bit wrong.
No, but that's actually completely normal. One of the unfortunate things that's happened with networking in the last 40 years is that we've sort of gotten better and better at lying to the application development folks about what's really happening, and so they often have no idea what actually happens under the covers, and that's actually a good thing. You really don't want to know how the sausage is made.
So before network service mesh happened, the Kubernetes network model was newer, and you said like it's very successful, crisis of success. And the Kubernetes network model, we kind of so Kubernetes starts at the IP address layer, but in
Mm-hmm.
Kubernetes, every pod can talk to every other pod in the whole cluster by default. And then you have to apply limitations for what you want to actually be able to talk. And you do that with network
Mm-hmm.
policy. And within network policy, you do that with labels and selectors. And then the other big
Mm-hmm.
part of the Kubernetes network model that we mentioned here is that Kubernetes has services, and the services provide one stable IP address for a set of workload pods.
Mm-hmm.
So it's really wonderful, except when it's not. Like if you're, it's really just super fabulous. But if your particular use case doesn't happen to work for this model, then it's not a very flexible. There's not much recourse for you. So also at this time, the service meshes were starting to be built, and they're all at the OSI model L7 layer, which means that they're doing most of their connectivity through gRPC and HTTP calls. So the problems here are summarized over here. So it's more expensive to process at L7. It's hard to move traffic between workloads in different clusters and different cloud providers. Workloads are tightly coupled with Kubernetes networking, and telecommunication companies want to process at the L2 and L3 layer, maybe other companies too. So those are some problems we learned about. And then in order to understand network service mesh, we first need to understand what a network service is. So network service is a blessed thingy that processes IP packets, which is layer 3 of the OSI model, which processes IP packets and then adds security, observability, and networking. So basically, a network service is anything that like gets an IP address and does something with
Yeah,
it.
it gets an IP packet and something happens.
An IP packet, excuse me, not address. Yes, and something happens. Is that better than saying it does something?
I mean,
Semantics.
it's part of it is the way you think about the world. In some sense, if you think about it as being a server, like the
Uh-huh.
entire world is just you shove a packet down a wire, and
Uh-huh.
magic happens, and maybe you get other packets that come in on the wire,
Uh-huh.
and we interpret that as connectivity and other things. So yeah,
Uh-huh.
the network service is just the thing on the other end of the wire, whatever it may be from your perspective.
Okay. So really, so the thing it does could just be shove it down in the package. But is there like there's compute behind a network service? There's some sort of like thinking smartness. Yes.
Well, yeah, I mean, there often is quite a lot of it. Often there are
Okay.
specialty agents that are switching the packets and also subtly changing things about the packets depending. And
Okay.
there's a lot of stuff that can happen to a packet. A packet's life can be very eventful.
Okay.
And it gets passed along to other people who do other terrible things to the packet, and it's all quite exciting. It's sort of like being shoved through a complicated series of water slides.
Sounds
If you're
very
the
fun.
packet.
So, so then network service mesh then is a technology that allows workloads to connect to 0 or more network services. And so I guess, I mean, it might be worthwhile to say workload independent of where the workload is running. Might be a
Independent of where the
worthwhile
workload is running,
addition.
the reason we use the word workloads instead of just pods is that we will often talk about things in the Kubernetes context. The workloads need not just be Kubernetes pods; they could be VMs, servers, whatever.
Yes. Um, I laughed out loud when you said 0 or more network services.
Uh-huh.
But by that you mean like you can be connected to like a workload. Well, a network service mesh could exist without the workloads existing, or the
Well, but
workloads.
more than
Yeah.
just because you're running a workload, doesn't mean that
Uh-huh.
it's connecting to a network service. You could just be using Kubernetes networking, right? If you don't ask us
Uh-huh.
for anything, we leave you alone.
Uh-huh.
So the other reason it's kind of funny is that the zero or more is just me being slightly pedantic. Uh, it's
uh-huh.
it's 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 slightly overly precise for normal conversation.
Or like by that definition, technically every Kubernetes cluster ever is network service mesh enabled.
Well, I mean, just because you're connected to zero network services doesn't mean you couldn't be connected to network services. Um,
Yeah. Yes, yes.
so,
I
and
hear
in
you.
fact, one of the interesting things we can do that most enterprise users don't do is we will absolutely let you connect to a network service or disconnect from a network service at any point in the last life cycle.
Oh, oh, okay. That's cool.
Not
Um,
something most enterprise users do, but the telco people are very happy about it.
oh yeah.
They've got a more complicated life.
Just in general. So then we talked about some workload, some user experience related things. So one is
Mhm.
as like a application developer, all you would do is add a single line of annotation to a Kubernetes pod, for example, that so whatever your workload is, that names the network service that you want to connect to, and that's it.
Mhm.
And that's because there's a network service registry. So when a it's
Mhm.
easy to add a network service when one is created and make it discoverable to the people you want to be able to discover it. And then it also uses Spiffy and Spire for workload authorization.
Mhm.
Say that.
Well, technically we use the Spiffy Inspire for authentication, and then we
Uh-huh.
actually we by default use OPA for authorization policies.
Ah,
Um,
okay.
but and those are also very lightly plugged. We occasionally get people who want to do bizarre things that are not Spiffy Inspire and OPA, and that's easy to swap out if you really care. But Spiffy Inspire and OPA do a good job, dude. Use what works.
If it ain't broke. Um, so
Well, some
then
people are
we
born broken, so you can't help them. Uh,
And so in terms of user experience, so the other related thing is that the Kubernetes, if you want to add a network service mesh to your cluster, it's a easy
mhm.
apply -k command. So all of
Yep.
it is designed to be simple to add and
And, and
use.
and we have a whole bunch of examples in one of our repos that we point to from our documentation of a whole bunch of different use cases you can try out and how to try them out and how to deploy them and everything else. And we actually have an interesting technology where we compile our documentation to system tests. So we know all
Mm-hmm.
of our use cases work because our
Okay.
documentation is compiled to tests.
So I would to really help understand like what NSM is or network service mesh is, it helps me to understand the use cases. So
Hmm.
so if you have a lot of workloads running in a lot of places, like different clusters, different clouds, maybe some are VMs, maybe you have physical machines. This is where, with using network service mesh, you could connect individual workloads in each of those places all to the same network service, so they can
Correct.
all talk to each other. You don't like it when I try to say they're connected directly. You
Well, the
corrected
thing
me
is,
many
you
times.
you
I
you
picked up on it the
can
last
no
time.
you can, but it's a common point of confusion because there's a very
Uh-huh.
small number of cases in which you would want to do it that way. Usually,
Okay.
you want to connect them to a network service that's connecting a bunch of other workloads.
Yeah.
So,
So, yes. So no matter where it's running, you can connect them to the same network service, and then therefore they have they're able to communicate with one another and also have that added security, networking, and observability with that communication.
mhm,
Um, so the reason you might want to do something like this, one really cool thing is that it can connect between organizations. So if you need to set up a service that is used by both a car company and its parts supplier, this is an easy way to do that and get to
mhm,
entire organizations, to different organizations to play well together.
mhm,
You also said, and in reference to the fact that all this is happening at the IP layer with packets being moved around as opposed to requests being moved around. The thing that's good about that is you can use an SM to connect multi-cloud apps, for example, to like a database that uses a funky protocol. And if you want to, you can use it in combination with, that's what I want to put in this space. And like why you would want to use it in combination with an application service mesh that's like Istio or Kuma or Linkerd. So one reason you could do that here in this use case, where you are still using the application service mesh to do your application layer connection,
but on top of a network service. Yeah.
But on top of a network service.
Because the thing is, when you're actually looking at layer 7 headers, like HTTP headers, there are things you can do with that you can't do if all you're looking at is packet headers, right? There's additional information there, and there are additional kinds of things you can do there. So they're very complementary. We will sometimes get people asking in a competitive comparison sort of way, like, well, NSM versus Istio, and the answer is they're complementary technologies. They're not competing technologies. We don't even vaguely try to do the thing that they do, and they don't even conceive of the thing that we do. So, but we're better together.
Yeah. And so, when a company wants to process packets, that's the third use case. So again, with a telecommunications, for example, company that does want to process packets, that's a great use case for NSM. So then now I'm like, okay, I understand that NSM Connect has network services that connect workloads all over the place. But then like, where is NSM running? Where is it? What is it? And so the answer is anywhere and everywhere you want it to be. So it could be a pod that processes packets in the cluster you want, or in another cluster. It could be a VM. It could be a physical server. It could be physical routers and switches. It could be a lot of different places. So it seems like the sky's pretty much the limit. But the idea here is the client doesn't know or care where the network service is running.
Yeah, because that would be unfun. We don't like unfun.
No, we don't want to worry about boring stuff. So then we talked about how NSM compares to, contrasts really to application service meshes. And so application service meshes, again, like Istio, Kuma, or Linkerd. The app mesh is operating at L7, but it's also it'll do some L4 stuff too, and that's a TCP. That's the transport layer, UDP, etc. And NSM is operating again at L3, the IP address layer, sometimes L2, but that's not worth going into today. App meshes are only one mesh per workload. So once a workload's connected to a mesh, that's the only mesh it's going to ever be connected to. And typically there's only one mesh per cluster. So in NSM, a workload could connect to many different network services at the same time. It can even connect to services in different organizations, like within the same company or like across companies. Mutually ignorant. I like that phrase too. They're coexisting in a mutually ignorant way. I think my neighbors seem nice, but that's pretty much what we're doing here on my block. NSM also scales fabulously well. So at internet scale, when the meshes can get bogged down by that, they have an entire networking layer, like with Envoy or something, that has a proxy in every single workload, and the egress and the ingress and the egress and all over the place, and that can weigh down a system.
I mean, and Envoy does a brilliant job of what it does. It's just a hard problem from a performance and scalability point of view.
To connect everything to everything else across clusters, across systems, across
at layer 7, because layer 7 is complicated. There's a lot going on.
Yeah, and that's everything on the board. And I think what we could write here, I'm open to ideas, but I think what we could write here is how they're complementary, and how L7 meshes and NSM are complementary.
That's an excellent idea, and effectively what it really comes down to is, if you're building a layer 7 or an application mesh, then your life gets incredibly simpler if you're
Mm-hmm.
operating over what they will usually call a single flat L3 domain. Um, and what's usually meant by that is that you have a consistent set of IP addresses that can route between each other without the need for NAT games. And that, there are various things the application service meshes have worked out to work around, not always being
Mm-hmm.
able to get that, but they have lots of complexities in operation. They have lots of performance hits as you move through gateways. Um, they're just complex, and the complexity scales badly. Um, Network service mesh can give them that flat L3 underneath
And
them.
and we're calling that like a connectivity layer.
I sometimes call it like a connectivity domain, or a
Okay.
communication domain,
Okay.
but and often I will hear people talk about it as a flat L3, and
Mm-hmm.
we can simply provide that to them as a network service, and then you can
Mm-hmm.
run your service mesh over it. Because the easy part about it is, if you think about it from the point of view of an L7 service mesh, remember how I talked about,
Mm-hmm.
you giving me a URL, I've got to go use DNS to resolve the IP address. Well, if everybody in the domain who's talking to each other has a unique IP address, and I can reach
Mm-hmm.
you from the IP address, that's really easy. I can just open a TCP
Mm-hmm.
connection to you.
Yeah.
But if it's not that way, if there are overlaps in the IP address space, and I can't just open a TCP connection to you to reach you, and instead I've got to go through a gateway to get out of my cluster and then a gateway to get into your
Mm-hmm.
cluster,
Mm-hmm.
that has to go process HTTP traffic. That is administratively complicated, and also puts performance hits at every hop in the system. And so we can just provide them a nicer, friendlier, more even environment to operate over.
And then what does the app mesh do for network service mesh?
Oh, I mean, effectively, the only reason we're here is to make people's lives easier. There are things at
Yeah.
L7 that make developers' lives easier. Like, and these are all sort of like a lot of the classic examples of, oh, gee, I want to do a canary deployment. So I'd like 1% of the traffic to this
Uh-huh.
URL to go to a different set of things. Well, network service mesh doesn't reason about URLs, right? That's up at layer
Uh-huh.
7. That's not our thing. Um,
Uh-huh.
there are a lot of useful things that L7 service meshes do that users like, and quite frankly, that we don't do and we don't want to do in network service mesh. Like, let
Mm-hmm.
people who are good at those things do them. And through the
Mm-hmm.
magic of layer separation and networking, we can make it easier for them, and they can keep doing their thing.
Cool. Am I on the board still? Yeah. So I'm running
You're
L7 provides
you're still barely on the
complex,
board. Yes.
yeah, complex routing and HTTP stuff.
Complex routing based on HTTP stuff, right? So,
But mm-hmm.
so
But
for example,
not just that though. Yeah.
yeah, I mean, it does a lot of other things. It can decide that
Uh-huh.
you're going to insert, various tracing tags. It can decide that you're going to route example.com/food to a different service than example.com/bar based on the URL.
Is
Um,
all of it routing related?
a lot of it is a lot of it is, but not all of it. Um,
Mm-hmm.
so a very generic way of thinking about all of networking, whether you're talking layer
Mm-hmm.
3, layer 7, whatever is, you take some kind of a message, you shove it in
Mm-hmm.
one end of a tube, whether the tube is an HTTP connection or a physical interface or whatever.
Uh-huh.
Whatever you shoved it into tweaks the message a little bit in various ways and then shoves it out another tube somewhere else, and eventually it gets somewhere, right? So
Uh-huh.
when you're dealing with L7 stuff, the things that are being shoved in are the HTTP messages that have headers and have content.
Uh-huh.
And so if you're an L7
Okay.
application service mesh, you can
Mm-hmm.
decide, you can change those headers and that content, and you can decide where to
Mm-hmm.
send it based on the information in those headers and this content. But you usually don't
Mm-hmm.
reason at lower layers very much. In network service mesh, the thing we get shoved into is an IP packet. So we don't really worry about what's in the IP packet that much. And so it's just worrying about different concerns in the system.
Okay. I'm gonna write HTTP reasoning. I will say
that's a good way of thinking about it. And it's funny because it screws with people's heads on both sides. I have a lot of fun trying to explain to old networking people that just because something is coming over the same TCP connection no longer means that it's going to the same application. That really mucks with their heads. Like, wait, what?
Does that mean when I think of a TCP connection, I think of each end has an IP address and a port. Is that correct?
This is correct. Each end has an IP address and a port, and you can sort of think of it as a tube that you shove bytes across, right?
Yeah.
You just stream bytes across it.
So it might not go to the same application if like a pod goes down and a different pod uses that same IP address in a cluster.
No, it can be more. Yeah. It can be more profound than that, right? So you think of a TCP connection as a pipe that you shove bytes into, right? So you open up the pipe to example.com, and you send one HTTP message over the pipe that says, "Okay, I want to get, https://example.com/foo," right? So you send that message out, and it turns out we kind of lied to you. Your TCP connection is not going to example.com. It's going to a proxy.
Got it.
The proxy that it's going to looks at the header and says, okay, I'm going to send all the requests for example.com/foo to Marcelo. Right? And then I send another message that asks you to get on the same TCP connection, because I think I'm talking to example.com, that says, please go get me example.com/bar. And the proxy has been configured so that everything looking for example.com/bar should, instead of going to Marcelo, it should go to Thindle.
Okay.
So I'm not talking to the same people.
Yeah.
Anymore, because the routing of the messaging is happening at layer 7 now, not just at layer 4.
Got it.
But it used to be, if you went back 15 years, it was absolutely true that if you sent a message on the same TCP connection, it was going to the same application.
Okay. And now who even knows? It's going all over the place. It's a wild, wonderful journey. Somehow. All right. I think it might be time to dance our goodbyes. Do you have anything you want to add or say, or another shout out to your community and ask for assistance?
Yeah. So I guess the thing I would actually suggest is, again, and I'll stick this in the so basically, we earlier in the chat we have the community link for the network service mesh community. If you would like to get involved, that is an excellent way to plug in. You'll find there where we hang out in Slack. You'll see there where the community meetings are. I know we've got folks like Thindle who are in Sweden. We actually are pretty European friendly in our meeting times. Because we do have actually a large number of members of the community are in Europe. And so that's just a good way to get involved with things. And again, the same link will show you how was it that Thindle put it? The intimidating number of boxes and connectors. Oh, scary amount of tree node boxes for the mini repos and how they fit together. So
there's the link. I got it in the chat. Excellent. Thindle, you were here the entire time. That's impressive. Thank you so much. I'm going to press the button. I'm going to thank everybody while I dance. Please feel free. Wait, what's not playing? There it is. Thank you first to Ed for sharing your time and your expertise with us. Yeah, such a gift. And thanks for the chat for hanging out. It was fun. And thanks to everyone who watches the recording. I appreciate you.